So we have trying to move to digital realm in terms of the control electronics, which is a big step up for this project. And of course, there was the atoms part as well. And controlling atoms is very, very difficult. We do it routinely these days, but it's still a very challenging thing to do. You need, as I said, extremely stable lasers, but also because they're so sensitive, atoms, to all these background fields, magnetic fields, gravity. We need to do a lot of compensation to get rid of all these background effects, which are sometimes what you want to measure, but for the inertial navigation, that was not what we wanted to measure. If you can imagine that compasses work by measuring, the magnetic field direction of the Earth, and in fact, if the aircraft is rotating, then the magnetic field environment around the atoms is rotating. You don't want that because you want to measure the acceleration, not the magnetic field in that particular case. So there was a lot of work involved in there for our partners who were working on this. But ultimately, we managed to demonstrate all the components, and it was really exciting. Over 3 years of hard work to get there, with many partner companies as well. In fact, a lot of them in Scotland, which is quite nice to be able to support these companies. So Fraunhofer's job really is to, as we mentioned, to bridge this gap between academia and industry.